Good morning, students. Today I am going to explain you how to differentiate a function of a function. Okay, and that is also the method used is chain rule. Okay, how you come to know that what types of function of a function is there? Let y is equal to sine log x. So see, this y is a function, trigonometric function, whatever it is looking, sine. Sine is a trigonometric function. But here not only the variable x. Sine x is not here. Otherwise it was a function, trigonometric function. So this is a function of function. Means at the place of variable, if there is some other function like logarithmic function, exponential function, algebraic function, okay, so this is a type of function of the function. How you differentiate it? So by chain rule, what is chain rule? First of all, chain rule is that if there are some functions like u is a function or y is a function of u, y is a function of variable u, and u is a function of variable x. Here you have to find dy by dx, means how will you find? So first of all you can differentiate dy with respect to du, and thereafter in multiplication this u can be differentiated with dx. Just see, quite simple. Never cancel out here that this cancel out, that's why you are getting no. Here just find dy by du, since y is a function of u is a variable, and thereafter u is a function, another function of variable x. So u can be differentiated with respect to x, while if y is a function of variable u, so y can be differentiated with respect to u. So this is your chain rule. Or if the some more variables, like if y is a function of u, okay, u is a function of v, and v is a function of x, then if you have to find dy by dx, simply just see, find, differentiate y with respect to u, and thereafter since u is a function of v, so differentiate individually this u with respect to v, and thereafter into differentiate this v with respect to x. In this way you can find dy by dx. This is your chain rule. And by direct method, how can you find, how can you solve, how can you apply this chain rule? Just see. Suppose by using this rule, how can we see? So first of all you will see that let after this first function, whatever the first one, just except this one, all others let u is equal to log x. So see here, u is a function of x this time. Only one function, that is logarithmic function, that's why u is a function of x. And now if this is u, so y is equal to what? It implies that y is equal to sine u. So this is 1, this is 2, or this one you can take as 1, this is 2. Now since y is a function of u, so find dy by du is equal to what? Sin u, u is a variable with respect to which you are differentiating, so cos u. And equation third, and what u? Du by dx, since u is a function of x, so you can differentiate this u with respect to x, log 1 by x. 4. Now putting these values in this equation, so dy by dx is equal to dy by du into du by dx. Putting here dy by du is cos u into du by dx is 1 by x. So it implies putting the value of u, since u is what? Log x. So putting at the place of u as log x into 1 by x. 1 by x you can write here. This is your answer. Okay. Some more question I am taking. Just like if y is equal to log x square plus 3. See, this is your algebraic function, not only x. That's why it is a polynomial in x. And this total logarithmic function. So this y is a function of function. Both are functions. That's why you can take it as u. So let u is equal to, after this whatever, take u, x square plus 3. So y will become log of u. And see, u is function of x, y is function of u. You can differentiate y. Thus, y you can differentiate with respect to u, 1 by u. Some equation like 1 and 2, here 3. Now du upon dx, x square is 2x, 3 is a constant, so its differentiation is 0. This is 2x. Therefore, dy by dx, finally you have to find dy by dx. This implies dy by du into du by dx. So dy by du is what? 1 by u into du by dx, 2x. Replacing the value of u, whatever, u is this. So 1 upon x square plus 3 into 2x. This is your answer. And without just taking it as u and v, we can apply direct method. How? Just see. How can you use direct method? In direct method, whatever the first function is, just accept this one, whatever here, these all, just consider or imagine just like x, this whole as x. First of all, just think. So, differentiate dy by dx is equal to, first apply the formula considering this whole as x for this function. So sin x, apply as sin x. So sin x formula for sin, differentiation of sin is cos. So write cos, and here whatever here all will come. So log x into, thereafter leave this thing. Since you have already applied the formula for this sin, so leave this. And now think about this one. After this all will taken as x and apply formula for this quantity, this function. So here log whatever here x. Luckily here it is x. So log x, apply the formula of differentiation for log x. Log x is 1 by x. So into 1 by x. This is your direct method. And some more you will come to know, like cos log e power x square. Okay, just now only this. See, there are three functions. Here exponential, here logarithmic, here cosine function, cos function. So in direct method, if you have to find differentiation dy by dx, how will you find? First, I have told you, except the first one, all other you will think as x. This all. Take it as x in your mind. So this, considering as x, apply the formula for cos x. So minus sine, differentiation of cos theta minus sin theta. So at the place of theta or x, this is sin x. What is x? This total is x. So write this total. Now the power x into now. Now leave this. Leave this. Since you have already applied the formula for this. Now the same way think for this one. Here this log and thereafter some function. So now only this just take as function and all other just consider as x. So log x. So log x 1 by x. 1 by x. This one you have taken as x. So log x into. Now leave it. Since you have applied the formula for this and consider this as x. So e power x exponential. We know that differentiation of e power x is e power x. So e power x. Okay. So here this will cancel out and only your answer is sin log e power x. This is. Some more numericals I am giving you for practice. Okay. See some numericals like this. If there is a question like this, then let y is equal to under root sin x. How will you consider it? You will consider it like sin x whole power 1 by 2. Now see, a variable power, variable is here a function basically. So a function means variable, you will consider it as a variable x. So x power n formula first of all. So dy by dx is equal to x power n means n and x whatever at the place of x, that is sin x, still it will come sin x 1 by 2 minus 1 into. Now since you have applied the formula considering this as x, so again differentiate this and in multiplication you write. So differentiation of sin x, what you will write? Cos x. This is your answer. Now similarly, see, if y is equal to cos x cube. So see, this cos something, that something let x. So dy by dx is equal to cos something, some variable. So minus sin that variable, whatever the function or whatever is there, x2. Now multiplication, not with this with whole. Now differentiation with this function x cube, to which you have already considered as x. So x cube differentiation 3x square. This is the answer. Now for this one, see, if y is equal to sin 3x plus 5 whole power 2. This is square means like this. So see, here this one has x power n. So first apply the formula for x power n. X power n, n, x that is what? Whatever here. This total is as x. N minus 1 power 1 into. Now the differentiation for this one. To differentiate it, there are again two functions. So function of the function, not two functions, function of the function. So for sine, this taking as x, sine cos this 3x plus 5, and thereafter since this you have considered as x, so again differentiating this into 3. Since for this 0, x 1, differentiation of x is 1, 3 in multiplication, so 3 will come out. This is the answer. Now I am going to tell you differentiation of a modulus function. Differentiation of a modulus function. If y is equal to this mod of x, okay, so what can you write? You can write it as plus minus x. Plus minus x means you can write it as x square under root. This implies that the same function we can write it like this. Okay, and now differentiating it again, since you know the law of differentiation, rule of differentiation, this or this. So now n x power n minus 1 by 2, and in multiplication what will be its differentiation? 2x. So now 2x upon 2, since power is in negative, so it will come down in numerator, this under root, and this one is 2 to cancel out, x upon, what is this? This is your mod of x, so mod of x. Okay, therefore this is your dy by dx. This is the formula to find differentiation of a modulus function. Okay. So in this way you can solve all numericals from exercise 8th B. In 8th A, 8th B, all numericals you can solve. Here one thing, x should not be equal to 0. Okay, otherwise the function will become undefined. Right? So these two exercises, 8th A and 8th B, solve all numericals, practice these all methods, and thereafter I will give you some more lectures regarding other exercises. Thank you so much.